Okay, in this last presentation we're going to go ahead and bring it all together. So this is the last one for graphing quadratic functions in vertex form. So this one we will want to find the vertex, the Y-intercept, and the X-intercepts if possible, as well as the axis of symmetry and the symmetric point. Alright, so the first example we have is x minus 3 squared minus 4. So starting off, we have our direction. This opens up. Our y-intercept, if we plug in 0 for x, we get y equals 0 minus 3 squared minus 4. If we simplify this, 0 minus 3 is negative 3 squared, which is equal to 9, minus 4, which is equal to 5. So our y-intercept is 0, 5. Our vertex, recall that we are going to change the sign of the inside number, so it's going to become a positive 3. We keep the sign of the outside number, and so it is negative 4. Our x-intercepts, we're going to plug in 0 for y and solve for x. So I'm going to use my square root property. I want to add 4 to both sides. I'm going to take the square root. We get 2 equals, plus and minus 2 equals x minus 3. And if we add 3 to both sides, I get 3 plus and minus 2 equals x. So 3 plus 2 equals 5, and 3 minus 2 equals 1. So my x-intercepts are 5, 0, and 1, 0. My axis of symmetry, we're going to have x equals the x-coordinate of the vertex. So that gives us enough to start graphing this. So let's go ahead and plot what we have so far. We have a y-intercept of 0, 5. We have a vertex of 3, negative 4. And we have x-intercepts of 1, 0 and 5, 0. I have my axis of symmetry, and I can find another symmetric point. Notice that to get from the vertex to the y-intercept, we have 3 to the left. So if I go 3 to the right, I have a symmetric point at 6, 5. Alright, if we go ahead and graph this, should look roughly like this. We label our points. From there we can determine our domain. Our domain is, again, negative infinity to infinity. And our range is going to be, since this is going up, we're going to start at the y-coordinate of the vertex, which is negative 4. We're going up to positive infinity. Okay, so this is one that has everything that we need. It has Y-intercepts, it has X-intercepts, it has a vertex. But in terms of graphing these, sometimes, as I said, the X-intercepts are not going to be nice. And so in order to graph a quadratic function, you do need the vertex, you need the Y-intercept, and you do need the symmetric point. So the rest of these examples, that's what we're going to look for. If we come down to example I, we're going to go ahead and determine our direction. Since this is positive, this goes up. My vertex, we're going to change the sign of the inside number, so it's going to be -2. We're going to keep the sign of the outside number. It is -2. My Y-intercept, if we plug in 0 for x, we get y equals 0 plus 2 squared minus 2. If we simplify, 0 plus 2 is 2. 2 squared is 4. Minus 2 is 2. All right, so we got our vertex is -2, -2. We've got our y-intercept, which is 0, 2. And we have our axis of symmetry, which is x equals the x coordinate of the vertex, or -2. All right, so let's go ahead and graph what we have so far. We have our vertex at -2, -2, and we have a y-intercept at 0, 2. We have our axis of symmetry, and now we want to find a symmetric point. So when we are 2 to the left of the vertex, we are at +2. So I want to move 2 to the right of the vertex, and we will be at 4, 2. So my symmetric point is 4, 2. All right, let's go ahead and graph our parabola. And we get this. We label, so our y-intercept 0, 2, our vertex -2, -2, our symmetric point is 4, 2, our axis of symmetry is x equals -2. Our domain, again, since this is a quadratic or a polynomial function, this is going to be -infinity to infinity. Our range, since this goes up, we're going to start with our y-coordinate of our vertex, -2, and we are going up to +infinity. Okay, last example, we have f of x equals -2 times x plus 2 squared plus 4. Again, for this one, I'm not going to worry about x-intercepts. I'm just going to do the bare minimum. And so we're going to start with direction. Since that is a -a, the -2 tells me this goes down. My vertex, we're going to change the sign of the inside number. We're going to keep the same sign of the outside number, so we get -2, 4. And then the only thing that we need to do some work on is our y-intercept. So I'm going to plug in 0 for x. We get -2 times 0 plus 2 squared plus 4. We simplify inside the parentheses. We get negative 2 times 2 squared plus 4. We square. We get negative 2 times 4 plus 4. We multiply. We get negative 8 plus 4. And negative 8 plus 4 is negative 4. So our key points that we have so far, we have our vertex is negative 2, 4. Our y-intercept is 0, negative 4. Our axis of symmetry is x equals the x-coordinate of our vertex. Alright, so let's go ahead and graph what we have so far. Our vertex, negative 2, 4, is going to be 2 to the left and 4 up. Our y-intercept of 0, negative 4 is on the y-axis. And we have our axis of symmetry. We still need a symmetric point. So if we look at this, if we go 2 to the right of our vertex, we are at negative 4. So I want to go 2 to the right of my vertex. We will also be at negative 4. So my symmetric point is negative 4, negative 4. All right, let's go ahead and graph. If we graph this, we should get something that looks like this. We label. Our vertex is negative 2, 4. Our two symmetric points are negative 4, and 0, negative 4. Our axis of symmetry is x equals negative 2. Finally, our domain. Our domain is still negative infinity to positive infinity. And our range, we're going to go bottom to top. Since this goes forever to the bottom, this is going to be negative infinity. And it goes up to the y-coordinate of the vertex, which is 4. All right, that takes care of graphing quadratic functions in vertex form.